Certainly did not work. Okay, we're up on Restream. We are up on YouTube, I think. Yes. And we're up on Twitch. Excellent. And this is our nice stream. Oh, thanks for Hangout. It never went through yesterday. Well, we have code Hangout number 69. Let's keep it nice and friendly. All right, so today, let's hope we can finish the main features of this little micro solver. So just to remind myself, what did we build yesterday? Yesterday, I think we just have the basic solve implementation. So it basically solves for the cells, for the selected cells, using our visibility tool, but ignoring cages. So now the question is, yeah, Ranks suggested that I ignore cages first of all. Let me just see. So basically, if we have something like this cage, and there's an 8 in it, I don't want to just replace it with value 6. I think we should only use the cage sums if they're less than the minimum in the cage. Although we might ignore. So for example, let's say, let's make this a bit bigger. So let's say this is the smallest cage, isn't it? Yeah. So imagine we have this cage, right? And we have a 4 in here. And then this is a 7 or an 8. And I select these 3 cells. This cage, should that be counted as A, a minimum of 11, 7 plus 4, B, a minimum of 6, or a maximum of 6, right? Or C, 11 through 12, basically. In fact, this is a question I'm going to pose to Ransk. I'm just posting this to Ranks to get some feedback. Oh, Twitch chat didn't go through. Why is that? Come on, restream. Okay, now it went through. And, okay, now it went through. That's strange. Maybe it wasn't up and running just yet. All right. So, in this scenario, A. Let's see. Let's see what he thinks. Well, I mean, I can't. Well, I have options, right? That's a good idea, actually. I can use this, if there's a stored solution, I can use the stored solution to check if the cage sums make sense. But that's probably a later step, and that probably should happen at a different level where I'm just confirming rules. I mean, the solution... Because there's always the option that somebody might just fill in some value somewhere and use them for a little bit of maths. And basically not care about the cages. So I'd like to do the smartest thing possible at each situation. All right, well, step one is to actually include cages. So the easiest, obviously, is cages where the contents of the cage is less than the total sum of the cage. And then we can just max between the two, right? All right, so what we did yesterday was basically just a brute force simple solver. Now, the bigger I go, yeah, the slower it gets. And in fact, we should probably output something to that extent so we know what's happening, right? So we're doing solve steps. And every time we're doing a solve step, yeah, this took a long time. So, all cells processed, yada yada. So every time we step in here, we're incrementing this. Here's where we're incrementing solve steps, I think. Except we're doing multiple steps once we get here. Let me think. Is this 1 step, 9 steps? Or is the step when... I think it's the easiest if we just do this, right? And then down here, we're going to do a timer. I'm just going to call it solve step, even though, you know, it's plurals, etc. Nope, step count. Okay. Now, if I refresh this, it's not going to have a huge selection there. Right, so step count 11. So for example, this is already 1,300 steps. 49,000 steps, and it took 361 seconds. Yeah, so one control A will basically crash it instantly. So we definitely want to be able to skip out, right? Just to have a sort of a sanity thing going on here. So if I select 9, right? 9 is 280 and it takes 2 milliseconds. Okay, no problem. 700, 5 milliseconds, 24. Yeah, then it goes up really. Yeah, then it goes up real quick. 50,000 steps, 300 milliseconds. 50,000 steps. So 50,000 is probably a sane limit. And then here, basically, if step count is greater or equal to 50,000, return. And it'll try a couple more times. And I don't even know if it'll find a full solution. So I don't know what that'll say about the min-max values, right? So if I do this, we'll probably, yeah, immediately go to 50,000 steps reached. And min-max 90. If I do this, 91 to 9. So the numbers are actually still correct, which is quite interesting. So we could potentially skew the heuristics in such a way that we're very likely to reach the minimum and maximums. But yeah, so by excluding full cages, and I think this includes our rows, columns, and regions, we probably can speed things up. Now, so I wanted to look at it after having found the solution for the area, but we probably want to do this ahead of time. Now, the other question is, because I was just thinking, what if we, let's say, if this is a subgroup, right, can we solve this thing first? And these cells see things on the outside. But what the cells themselves see... Yeah, So for example, let's say if our selection is this, then obviously what goes in here depends on what goes in here. So we cannot just solve for this cage independently first. So we basically have to make our determination if a cage is included or not before we start solving on it, right? Now, we have an algorithm that finds our overlapping cages, which is this guy, right? So if we do this higher up, before the find min-max, right? Oh man, this thing is becoming such a mess. I need to clean it up before I go crazy. So this happens fairly quickly, and we can do it right early. So let's say, if I do this selection, and let's just push that in. So now our overlapping cages are 2. We have a 2-cell cage, which is the 6, and we have a region. Okay, so now the question is, can we eliminate that whole region without considering it in terms of the other cells? Because I'm obviously thinking about the overlapping here's, right? Yeah, the problem becomes with overlaps, right? So let's say if we're selecting this, then what goes in here depends on what goes in here. We cannot exclude that whole row right away. So that's a little bit tricky. This is actually not trivial. Let me see what rank sets initially. I wonder if he's thought about this or sometimes he just says things to me and then I try to implement them and I realize, wait a second. Just interesting on repeat groups. I guess I'm just saying, could remove full houses and cages with known sums from the selection as a pre-pass and add their fixed sums to the total, so the entire grid selection actually will be a quick. Yeah, the edge case are the problem, is all the overlapping. And if you don't have overlaps, you probably... Yeah. So the question is, right, this is 45. Can I do a shortcut by using 45 for this? Then solving for the remainder. And then afterwards kind of narrowing this down. Because it cannot, this cell, yeah, so what I'm talking about, right, is if I'm looking at this region, so if I selected this whole colored region, this is always going to be 45. Now this, I don't know what the minimum maximum is because it actually depends on this. So if I just take 45 out and then only look at this cell, okay, it can't be a 6, but otherwise it can be a 1 and 9. But in reality, it cannot be a 9 because it's part of a 10 cage. So can I then solve for this cell independently? Because obviously what goes in here doesn't actually affect this, does it? I mean, this purple will appear somewhere in here, but that's the thing. Like, how much can I do without actually implementing a lot of smarts in this algorithm? This is supposed to be a dumb, fast, quick, simple algorithm, right? So, how are we going to do that? Any ideas? My first instinct is to try to remove large cages first, initially. And obviously, if you have multiple overlapping cages, so the simplest heuristic would be to remove the largest cages first, And then basically redo our overlapping cages calculation. So how complex is this? This is ON squared or whatever. It's not too bad. Hi, Gija fan. Messi or Ronaldo? I vaguely know those are footballers. That's about all I can tell you. Yeah, this is not a sports stream, in case you're confused there. So, okay, so what is the most primitive heuristic we can try here? I'm not Swedish. I'm German. Sweden adjacent, more or less. Almost. So I guess the simplest heuristic would be get our overlapping cages. So let's not do the min-max here for a sec. Find the largest of these. Remove the largest one from the sum, add that in as a fixed value, and then repeat that process until you have non-caged cells left. And this will also ensure we don't have any overlapping cages, because when we're removing this remaining cell won't have an overlap thing anymore. So, I'm not sure what the question mark is for. Oh, to finish the question, I imagine. So let's try that. So overlapping cages, right? So if I do a control A, we have a whole bunch of overlapping cages. Now the we could say the problem is that one of these cages might be the entire board, but that's not really a problem, right? If you select the entire board and we know the sum of the entire board, then that's just our sum. So, well, is there an easier way of finding the largest without finding all of them? Don't think so. The only thing we can do is we can skip out once we have more than half of the cells, or once there's less cells left than the size of a cage, but we might as well just get all the cages, right? So let's do a little function. Get contained cages. And that's basically this. Because they're not technically overlapping, they're the contained cages, right? Let's rename that to not confuse ourselves. Oh, I hate scrolling sideways. I'd like to make the text smaller, but for the stream, let's keep the numbers here. So we'll do that. Get contained cages. Shouldn't actually be a function. Here we go. And okay, so now we kind of want to find the largest. Is there? Let's just sort them and get the largest one, right? So contain cages, sort, find, let's sort by length. Did we not do this before? Sort by most options, sort by length. Okay. Length minus a dot length. So now, if I select this whole thing, the longest should be this one. If I remove one, the longest should be the 5. If I add these in, 5, 3, and if I add this one in, the 9 should be at the front. And if I select all of them, yeah. So, after this, we want to remove one cage from our cells. And for now, we're just going to blindly remove those cells. Okay, so let largest cage equal the first one here. And we'll just actually gonna just do this. right? And then we have our largest cage here. And then get contain cages. What does it operate on? Some cells. Okay. And then we want to remove those cells. So now we'll say some cells dot filter cell largest cage dot includes cell. Something like that. So we start with some cells up here. And then we'll do, for now, let's just remove them. And we need some other selection here. If I do this, right, we'll have 2 cells and we'll remove. So this leaves 4, which is this and these 3. Okay. So we have our selection locked in. And that is our steps here. Let's pull the variables out so they don't make a mess of our algorithm here. And then we'll just repeat that step and see what happens the second time around. So now we calculate contain cages again. Ooh, didn't like that. Oh, yeah. So step 1, these are our cells. We have 9 cells. We have 2 contain cages. The largest has 5 cells. We remove it. Now we have 4 cells left. We have 1 contain cage with 3. Largest cage is 3 cells. And then some cells gets removed again. And now we should be left with 1 cell. Now if we do contain cages again, we should end up with 0 contained cages. So this could be something quick and dirty. So if I wrap this up, get rid of these. So if we make a little function here, const remove largest cage, and the return value would be, well, we could modify the cells array and return the sum of that cage. And it would make sense to maybe only remove cages whose sums we know. So we'll start with cells. And for now, we're gonna do this. Two of those. And this one. Remove large hash, yada, yada, yada. And then in here, basically we do these things. Like that. Largest cage, sort by length. And then return. But before we return, we need to do a few things here, actually. So get contain cages uses puzzle info.cages. The question is, how reliable is our sum information? Because the rows and columns, I think, have sums in them. So this only has the actual list of cells, not the actual underlying cage data. And the underlying cage data, what does it look like? We have cages, but only with the cells. Okay, so puzzle info does not actually contain Does not actually contain cage sums. So when I removed cages before in the previous algorithm, how did I do that? I don't remember. Cogs and groups, fixed group, min max, cage val, cages, cage index, cage val, cages. So I was using index. So cage index would be puzzle info.cages index of largest cage. Right. And cages is from the puzzle. Yeah. And cage itself. Whoops. Goes here. So what do we get? This is our cage. It's unique, true, yada, yada, yada. Cage wall is 15. All right. So what we can do is... so we have, okay, we can either manipulate this area in place and remove the individual elements, which is going to be a little bit of a pain in the ass. Or we return that and like a tuple of the sum and the cage. Let's just do that for now. It's not the most efficient way of doing it, but it'll do. So if I do this, then our output from there will be an array with the amount of value that we've removed from our total collection. And then the remaining ones are these. All right. So let cells equal these. Then we'll pass that in here. And then let deleted equals 0. Or excluded val. And then we'll do excluded val. And here we're gonna do total. We'll do something like this. And then instead of sum cells, we look at cells directly. And see what that looks like. So we have this, excluded val is 15. And now if we do the whole thing again, and we're using cells instead of sum cells, right? We do the whole thing again. What happens this time? So the first time, we end up with 4 cells. And then the second time, we end up with 1 cell. So we can do exclude total, excluded val. We'll do that again. And then the fourth time, I'm checking now how it'll handle the final step when we have no more cages to remove. So we end up with excluded val 10, cage index is -1, and we can return undefined, etc. Okay. So largest cage. Largest cage should be undefined, and contain cages would be an empty array. Contained cages is an empty array. Yeah. So this is when we want to exit. If contained cages length was 0, return 0 cells. Okay. So obviously, I'm not entirely certain there aren't other cases where this will fail. So I'm, instead of thinking about it too hard, I'm just going to try it different ways. Let's not show this anymore. That's super spammy. So we start here. We find cage 109, we exclude it. We find cage 13, we exclude it. And then excluded val is 0. And then we can basically do this. Repeat this, or do this, while excluded vals greater than 0. Excuse me. My nose is itching. Here it's coming. Excuse me. So we probably want to do this. I'll put these in one line. Bring this in here. And then we'll just do if excluded val is greater than 0. And then at the very end, we'll just have excluded total and the remaining cell. And that should just remove all the cages. And whoops. And I hope it won't generate any kind of infinite loops or anything like that. So now this excludes, this gets us down to one cell and an excluded total of 15. And if we now find min-max of the remaining cells, it gets us 129 on the remaining cell. And then if we do min plus equals excluded total, and max plus equals excluded total. So this selection would get us 26 to 34. But I don't know if that's accurate. I think in this case, well, no, because the minimum here is 4, actually. In fact, it's not even 4. This is a 1, 2, 3, 4, 5 cage by necessity. So if I remove that, by the way, I can clear these colors. So if we select these cages, let's just do this, right? So this selection, the 15, takes up 1, 2, 3, 4, 5. So this can only be a 7, 8, or 9. So this is not correct, right? Now, what I could do is I could solve for the cages individually, but then don't know if I can work my way back without evaluating the cages completely as well. Now, what I could do with the cages, like applying the solver to the cage is not a big deal. Because with the cages, obviously, I have two options. I have my killer calculator, which can find all the possible ways of filling that cage. And then I can find, the lowest and the highest. But then, even then, I potentially have to iterate through them because different configurations could cause other digits to have different amounts of leeway in terms of min-max values, right? Like, what I'm trying to do is right now mentally is there a way of calculating this more accurately, taking these other things into consideration, that will still work, that I can select a huge amount, if I do a Control A right now, not a problem, because it it is a problem. Why is it a problem? Excluded total 0. Wait a second. 1 second. What's going on here? If I select all of them, we have these cells, remove largest cage, what would excluded value be? Largest cage. Sorry, one sec. Just get rid of that error so we can actually... Oh, because it's not selecting everything. So now that everything is selected... Large cage is a 9. Cage index is 0. Cage val is undefined. Cage val doesn't use sum. And I don't know why I'm so inconsistent with value and sum. That's a bit weird. Whoa, what was that? I'm getting some noise. I think there's some loose wires in my microphone. How long have I had this microphone now? Quite a few years. Ugh. I hope it'll keep up. Alright, so cage val. Cage val, cage val. Cage val. Get cell val, get cell info. Where's cage val? Oh, okay, I'm an idiot. Alright. Cage value or cage dot sum. Cages. That's okay. Just combine these. If cage value number is pos int is positive integer, is that R? Or is int pos, I think? Is int pos cage.value. So if it's a positive integer, we use that. Return this. Else is int pos cage.sum. If that's the case, we return cage.sum. And then finally, return 0. All right. So now, those cages, it's using the sum value. It removes them all. Excluded total is 405. Is that 9 by 45? Yes, it is. Okay. All right. So, let's get rid of some of the spam. And if I do this, I'll do that. Less spam. Okay. So now if I do this, it'll come to excluded total is 45, and then the remainder is whatever we can calculate down there. It'll definitely solve the problem of like selecting everything and it's, you know, and it's just crashing, which is definitely something we want to fix. So interestingly here, it still reached 45 steps, 50,000 steps. So that's curious. Excluded total 45. So probably what happens is we're excluding this, and then the remaining 7 cells are still enough. Which is a little odd. I wouldn't expect these... Now the problem is, because we're not actually still filling in values for the removed totals, it doesn't contribute to shortening the solver time. So basically what it does is it removes this line and basically now tries to solve for these. Except You see right now, it does that in 2,863 steps. But if I add that row and then remove it, for some reason it jumps up to 50,000 steps, which is very odd. Because there should be no, unless I'm using some cells somewhere else. I was going to say find min max should just use the cells I'm passing in, but it could be that I'm using some cells somewhere else as a sort of global thing. Get contained 8 cages. I'm tempted to rename it so I don't have the risk of input cells. Let's change it to input cells so I don't run the risk of reusing it as a global somewhere. So get contained cages, cells. If I do this, now this will probably be a bit broken elsewhere. I think in this case it'll always remove the row because it just looks at the size of the cages. It just looks okay, and the sorting will always give the same one first. I think there's probably just a mistake with me using the variables in the wrong places. So input cells. So I just gotta clean that up quickly. Okay, so if I add this back in, it goes back. So this is very strange to me. This and this should be equivalent, but somehow they're not. So there's something screwed up somewhere. Now some cells right now should only be used or not be used in any actual code. It's active. Okay, so where else are we going wrong? What's the difference? So find min max. Find min max. Find min max. The only input is cells, but I don't know how much, if there's some connection to surrounding code, because this was very quickly built. If I do this, okay, so I select these 7 cells, and find min max is this. Okay, now if I add these, find min max should be the same 7 cells. So let's just look at these, row 6 and 5. Oh, wait a second. Ah, no, it removes the box. Ah, okay, maybe you're right. So if I remove this, ah, you're right. All right. Now the problem is, I don't know if there's an easy way of figuring that out first. Probably here because the cells have fewer dependencies, so there's just more options. And the ironic thing is, because we're not placing cells in the middle here, this might actually take more steps than this. Or this, right? So you see, this is done in 12,000 steps, but if I remove these 3 and add this one in, we have so much leeway because we're not filling in those cells. Huh. Yeah, that's something I have not considered, that removing a cage might actually make the solve time long, or the number of solve steps larger, because those areas aren't talking to each other anymore. So that's kind of the fundamental problem, is to try to remove a cage without taking its contents into consideration. So the other way of looking at which cages to remove is by looking at the dependency graph. So right now, basically I have 2 kinds of dependencies. So the dependencies I'm generating are, where are they? I think I'm doing them inside find min max. Yeah, options seen affected, right? So the dependencies I'm calculating is that So let's do scene to illustrate quickly and affected. So affected is outgoing and scene is incoming, right? Right. So let's say if we look at these, right? Scene and you know, affected is 0. Ah, wait, because of the way it removes them, right? So scene is this. So each of these cells is seen by 20 other, or sees 20 other cells. It's kind of a reverse thing, right? So it just means that I have to look at these 20 cells to determine what this cell can be. And that goes up and down, left and right. And I might, at this case, kind of remove, well, it's tempting to remove blank cells, but obviously those blank cells might get filled in. No, actually, I can remove blank cells outside of our region because we're only manipulating our region. That's one optimization I can do. All right. And affected is basically, okay, these are the cells seen, let's say the first cell sees these cells, right? So cell 0 sees 1, 2, 3, 4, and 5 or whatever, right? How does this area index actually? Why are there exactly 5 elements? That's a little odd. A little coincidental, don't you think? Now they're all 4 elements. One second. Affected are the scene cells that are inside our selection. But shouldn't that include all of the cells in the row? And those are more than 4. So if I look at the first one, these are all the cells that this cell sees. And of those cells, these are the cells that are also in the selection. That doesn't seem right. That does not seem right. How are we mapping these? Index of cell, scene index, filter. I think there's a conflict because I think I have the global cells area here somewhere. All right, let's change this to input cells. So input cells, scene cells, include. I probably have something really silly where I'm just reusing a variable somewhere that I shouldn't be. No. Okay, so this makes sense. Now, if I add 1 here, why does this suddenly go down to 4? Because in this case, yes, each of these cells sees 6 other cells. But when I select this one... Oh, because I'm an idiot, because I'm selecting a full cage. That cage actually gets removed. And now I'm looking at these. These are 5 cells. Each one can only affect 4 others. Okay, mystery solved. All right. It still doesn't explain why this whole thing... So if I remove these, it goes up to 28,000. Is that even true? Is that the possible combination of filling in 6 cells like that? Huh. All right. Yeah. So, well, there's nothing with the scoping rules. My variable naming is terrible. There's only so many different ways you can refer to cells and groups of cells and cells and cells and cells, right? So currently I was selecting the largest cage first, but what I really want is the cage with the largest number of dependencies, right? But before we do this, I actually want to reduce this because I can remove... Now, I'm not taking into consideration pencil marks in these other cells outside, so that's fine. I don't think that's super helpful. It would be too complex to actually include those. But I can definitely exclude cells that don't have a value, right? So let's see where we're using the scene cells, and it's probably one of these. Yeah. So what we can do is we can just filter them out here. So filter where C is not the cell we're currently looking for, and get cell val. Whoops. Get cell val C is not equal to undefined. So now the number of scene cells should actually be much smaller. So it doesn't reduce the number of steps required, but it speeds up how long those steps take, probably quite a bit. You know, you're doing 50,000 steps in 130 milliseconds. So doing that filter up ahead of time is definitely worth it. So let's crank up the number of steps we can use. Where's that limit? Inside solve step, right? Let's go up to 100,000. So 78,000. Now if I do this, all right. So 78,000, if we go here, 100,000 steps reached. Mm, 300 milliseconds, not a big deal. And our range is 52 to 93. I mean, the range is probably still good enough. I just would hate it to miss something that's really easy to see as a human. I mean, obviously, 99% of the time, the calculator is not going to be used on a mostly empty selection. So that's the other thing, right? If the selection is mostly empty, you're going to get big ranges. Like, you can't really expect any better. It's just, I don't want it to blow up if somebody, accidentally clicks a couple of cells, right? And it would be nice if I could exit out a little bit sooner. No, that's perfectly fine. I'm just stepping out if we're reaching over 100,000 steps, right? And since I'm stepping out on the call and I have a loop down here, it'll hit multiple times, right? No bug there. I mean, I'm just skipping out right now just to avoid having to wait a long time or infinitely long. Yeah, so the problem right now with this heuristic is it actually slows things down occasionally. It doesn't even speed things up. And it's mostly for avoiding situations that will not ever occur in realistic use. I say that, but there are some puzzles where you might want to where you might want to select all the cages, for example. And that could be most of the puzzle. And you want the reverse, right? You want to calculate how many cells are not selected. In fact, you see how slow it's getting now because it's taking 300 milliseconds to do the solving. And in this case, I actually do want it to remove the cages and add them up, right? So minimum 8, maximum 51. And in this case, wait, what? Did I remove the code that's removing the cells? Excluded total cells. One second. All of these cells should be removed. They're all in cages. So oh, you see? This is what happens. It's taking out the central region because it's fully selected, and then it's ending up with leftover cages or leftover cells, and it's ending up with these 8 cells that are completely disconnected. And then even just solving for those 8 cells actually takes that long, which is kind of terrible, right? Because it literally just enumerates 8 different ways of writing the digits 1 through 9. Because it's just temporary. This is not how the final code is going to work, so no point improving that. So actually removing the largest cage first is a problem. So maybe it's a question of removing cage. The problem is either this one overlaps this one the same way the large one overlaps these other one, right? So maybe it's about removing non-overlapping cages first. So if I calculate the number of overlapping cells in a cage, so remove largest cage. What if I calculate the number of overlapping cages, or number of overlapping cells per cage? So first of all, let's stop this again. And then here, let's do a... And then here we're just going to do return 0. And then here. So we're going to output the size of the cage. And now we're going to calculate how many cells in this cage are also contained in other cages. Yeah, but that's the thing. All cages are overlapping some cage, right? Because there's a cage that contains all cells. So every cage always overlaps that one, right? But it's not necessarily part of our list here. So if I do cells dot filter. So for each cell in this current cage, let's look at all cages. And we filter those. Because it's so we want to return cells2 is not equal to cells. So we want to exclude our cells, obviously, the cage we're currently looking at. But now we want to count if any of our cells2 dot includes cell not include cell. So that should filter out all the cages that satisfy this. Yeah, the thing is, all the things are true, but all of those things are actually quite a bit of work to figure out, right? I don't have a rigorous mathematical representation, that's the problem. So there's a lot of looping loops, and they can be potentially quite slow, but faster than solving hundreds of thousands of random number counting steps, I guess. Excuse me. All right, so it's returning the number of cells that's apparently overlap with other cells. So every cage has at least 2 overlapping cells. That seems not quite right. What if I output the contents of cells as well? Does that give me something? So, one sec. If I'll pop open these, that's 4, 4, 7, 4, 8. Could both cells overlap? Well, instead of filtering, what if I map them to my brain. So if this is true, I want to map this to the container just so I can take a look at it. Else return false. So I want to see what these cells map to. This does make sense to me. Contain cages. So these are all the cages that are fully contained in our selection. So each item in them is an array of cells. So this should be an array. Oh, because this is a filter. Oh, god damn it. So map the cells. So for each of those cells, all right, I need a function. I need a helper function. I need a function that, given a cell, returns all the cages that cell is part in. All right. So instead of this, so find cages with cell. Right, where cages are just list of cells. So we'll do return cages.filter cells cells.includes cell. So that returns all the filters that contain a particular cell. So now if we start with each, so once for each cage, right? And then for each cage, we're mapping the cell to all the cages that that cell contains. So cell, and then contain cages. Right? And ultimately, we want cells that only are contained in the cage that they're from, i.e. only in one cage. Yeah, and in fact, that's what happened here. The results I was getting was the cells in their own cages. So now I can say find cages with cells. So we know those cells are in at least one cage. So if that length is 1, then that cell is unique. Filter. Wait, we're filtering the cells where the length is smaller or equal to 1 of the find cages with cell call. If I map it to the length, that should return 1s, right? Yeah. These are both 1s, right? So this should be smaller or equals to 1. So this should be true, true. And now if I filter... Oh. Yeah, we want the opposite, greater than 1. And then filter. Well, that's kind of the problem, yeah. But I'm just thinking I want to try a different heuristics. Instead of just removing the largest cage, if I can find cages that don't have any overlaps themselves and remove those first, then yes, I destroy some other cages because now I've removed some cells that might be inside of them. But certain scenarios, such as something like this, you know. So for example, it will not remove the central region in this puzzle now, but it will remove all those individual cages around the outside. And it might be enough, right? It doesn't have to be perfect, right? It needs to be good enough. So now you see, now I have a bunch of cages that have no overlaps. So in fact, I can just, instead of removing just one cage, I can just I can basically remove all of these cages right away. So these are independent cages, right? So if that area is empty, I have no dependent cells. So if this is dot length equals 0, right? So these are all the independent cages. I guess I can just remove all of these right away without any problems. Independent cages undefined. Filter. Cells. Like that. Independent cages, yeah. So there's 11 independent cages. So what we can do is remove those. And instead of remove largest cage, we just say const remove cage. Right? And then basically what that does is we'll do this. We'll override cage. Or we just gotta... We'll just do this. Because there's two kinds of cages and all that. Yeah, I'm just hoping that if I remove enough cells, I can brute force the rest. That's pretty much what I'm doing here. So cage value is this. And then we can return... We can return largest cage. Cage cells. Cage cells. So cells.filter, not yada yada. Okay. So now we can do independent cages dot for each. And we probably want to do something like cells here. Independent cages dot for each. Cage. Now we want to basically do this. Cage val cells equal remove cage cells cage. And then here we'll do our let removed sum. Moved sum plus equals cage val. Now, what we should do is, if cage val is 0, we shouldn't remove the cell, right? So if cage val is 0, we return cells, otherwise we filter them. And then here, I think removed cells and cells equals removed cells, removed sum. So we basically want to output cells afterwards and removed sum. Well, like I wanna work on cages first to remove chunks of cells, right? And then the next step would be cells. But sorting cells by number of other cells seen might be interesting. The problem is the hard cases are when, you know, let's say if it's a straight line, then every cell sees every other cell, right? And those are the hard cases, where then you have to iterate through everything and you don't really get significant reductions at each step. But if we look at this now, we started with 58 cells and we ended up with 29 cells, which is quite a change, I think. So this is just removing the independent cages, right? So what we now have left is dependent cages. And I'm wondering if dependent cages we just can't remove. I mean, we're down to 58 cells. Is that enough? I mean, remove cages. Or simplify cages. So instead of remove largest cage, we'll just call simplify cages. We're actually going to just block this whole thing out here. Block this whole thing out. And then here we're going to return the removed sum and cells. All right, so let removed sum final cells. Let's just do this for now. So if we do this, you're removing cage in order that remove cells which are least constrained first. Well, right now I'm just removing all cages that contain cells. Because remember, I cannot remove the cage if any of the cells are constrained, right? So I can do this in bulk by cage, right? I don't need to look at individual cells just yet. All right, so this removes 131 from the total sum and reduces our cells from 58 to 29. So that's almost half the cells gone. Now, if we run min-max on the remainder, does this come in at under 100 steps? No, it does not. Well, I guess it's still way too many cells. Don't like it. Well, I don't need to sort them. I'm just doing all of them, right? Like, there's no order in this case. I just remove all of them. So this would remove cages like this one, and this one, and this one, 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 and this one, I believe. It should probably also remove these. And it should remove this one. And this one. Now this is 17 cells, so it doesn't remove these, right? So there are some cages here that aren't being removed, probably because of the rows, right? These overlap the rows, so it probably doesn't remove these, and it probably doesn't remove these. Oop. So of these, it probably only removes that one, that one, that one, and that one. And that one, and that one. These don't get removed because they're part of a row and overlaps with the row cage. So what I can do then is, if I remove other cages, I also have to, sorry, if I remove, let me think. So basically what I'm looking at right now is these guys, because they overlap with the row cage. Now, if I were to remove the row cage, I would be left with these 4 cells, which is actually better than not removing the row cage. But alternatively, if I remove these cells, I would remove more cells. So, hey Mark, how are you doing? So your algorithm, I don't think, finds this yet. So that would be an interesting way, kind of permutating the combination of cages that are overlapping with each other, that cover the most cells, right? So in other words, given, let's say, the blue cells, and knowing that there are cages that cover the rows, knowing that this overlaps, can I find all the cages it overlaps with that don't overlap anything else? Because, like, these overlap this cage as well, right? And then count if that number is larger or smaller. And is this algorithm fast enough that doing this across all the permutations is faster than doing something else, right? And I think the answer might be yes here. So the primitive algorithm would be, look at the largest cage, find all the other cages it overlaps with. So these, it overlaps with this one. So that's a bit of a problem, right? It overlaps with this one. Find all the cages that overlap with it, but nothing else. Now the problem is this one overlaps with the box cage, and so do this. So that might not be the right way to do. So we need to actually consider multiple cages all at once, which is a bit annoying. Pulls out the 4 around the corner of box 5 first. All right, let's. I don't know why I'm being stubborn. Let's have a look. Compute the number of other cells seen, sort smallest to largest. Loop over trying to remove it via a cage. The problem is not other cells seen. The problem is other cages seen, or overlapping with cages, right? Because in principle, all cells more or less see the same number of cells, right? Because, you know, the rows and columns and regions massively overpower the 1 or 2 extra cells that might be seen by a cage, especially in a case like this, right? Remember, this is a cage, and these are cages, and this is a cage, and these are cages, right? And in a situation like this, for example, it would be better to remove these and then add this one in than to not remove that row, right? So there's an inverse as well. It's easier to find the inverse sometimes. All right, let's just implement it and see what it looks like. So, where are we at? Final cells, right? So we're looking at final cells. So we have 29 final cells. Let's loop through them. So we need to index them into the original cells, input cells, right? So input cell. Right? And we're actually going to do this here. We have IDX. We have the position of the cell. And we want the affected array, not the seen array. Which is... which is getting calculated in here. All right, well, let's run it in there then. But then we have to run the min-max. Okay, well, fuck it, we'll run it. And let's bring the max step count down so we don't have to wait so long. Where's the step count? Cell step. Let's do it the other way around. Make it 50,000 minus. if step count is greater or equal to 0. This one goes after it, and we are solve step. So before solve step timing, we're going to output, and we need final cells. No, we need input cells, and we don't need final cells. We need... Oh, wait a second. We need the originals. No. I'm an idiot. No, because these are relative to this one. Okay, so we need input cells here. Yeah. So for each, input cells for each. So we don't need to do this, actually. We'll do this. And then affected IDX. So let's see what that looks like. It pulls out the 4 around the corner for other scenes selection. Yeah. Cell.r2rc. Why would cell.2rc not work on this? 2rc. Okay. So let's look. The cell in row 6, column 1, row 6, column 1, sees cell 15. So I'm guessing we'll map those. Input cells, IDX.2RC. So row 6, column 1 sees row 6, column 4. But it should see more than that one. What the hell? Row 6, column 2. You know what? Let's see if we can update the selection. So if we do framework.app.select input cells, I think that should update the selection. Deselect. Yeah. Okay, so that's after simplification. That's our final selection. Why is it running over and over? What the heck? Why would it run multiple times? Oh, I'm an idiot. Shoot. Obviously because I'm creating a selection event. And that just triggers everything all over again. Can I do this without triggering a selection event again? I don't think so. Can I just force it without actually generating a selection event? And then refresh it. Now I have to remember how to redraw the cells after something changed. So after an action was executed, cells have changed. Pre-state, clear cells, pens to action, undo, replay, undo selection, trigger, clear, select, highlight. Selected cells push, cell highlight is true. I think this should redraw the cells. Nope. All right. No, I do actually want to do this because it helps me figure out what's going on. There must be a draw, a dirty call or whatever somewhere. It should be rendering here. So, scene affected, input cells for each. That's these guys. And these are the selected cells, 29. And they should all be true, obviously. So how many are highlighted here? 29. Ah, this is not what I'm seeing on screen. The frick is going on here? No, I'm trying to get the highlight to disappear in these cells. In fact, it's not letting me deselect these at all, because as far as it is concerned, they're not deselected, which means the selection hasn't updated, which means I need to update the selection, right? So, and that is only happening on... is this one? Because it's listening to the selection action. And I want to trigger a selection action because that will create an infinite loop. Never mind. I don't want to hassle with this. What I can do is I can do cell.prop set color 1. Like if I do that, would that do a thing? I just want to mark the cell somehow. Jesus Christ. Let me just type. I don't know, the editor's doing all sorts of weird things. Input cells, prop set color is to 1. And then render content. Ugh, my API is horrible. No? Oh, finally. My God. Ah. Oh dear. All right. So we have prop set. And we need prop unset. We just want to remove 4 from all of them. So if I delete green, okay. Well, that's terrible. That's so bad. All right, okay. Because it's all freaking automatic now. So green are the cells we're considering. Sorry about this. I haven't touched that stuff in a while, so I'm a bit rusty. And we're looking at these cells. So row 3, column 2, for example, row 3, column 2, which is this one, sees no other cells. Now that's rubbish because it sees itself. I mean, it sees the cells in its cage. Row 3, column 2. Row 3, column 4. So what about row 4, column 2? That sees no other cells. That's just not right. So that's affected and seen. Oop. What is going on? So if I select all blues. Seen. Oh, affected is indexes and seen is by... Jesus Christ. Consistency. I do not know it. So seen are cells and affected are indexes. That's weird. Why did I do that? Anyway, it's prototyping, yada, yada, yada. So, seen are actually cell objects here and don't need to be dereferenced. Right. So now I can get rid of these again. Refresh this one more time. So I don't understand how 3C2 has one scene and 0 affected cells. I'm starting to think I got these coordinates wrong, that they're maybe off by 1 or something. Because all these cells are part of cages, and therefore they should be affected. And those cages are all part of the selection. So row 3, column 5. Row 3, column 5. So this is seen by that one. But it's not seen by this one? That's not true. It is seen by this one. Okay, I'm going to have to dig into this a bit deeper because I think my scene cage cell algorithm here is inaccurate. And I wonder if it's a bit broken by me manipulating which cells are in and out of this overall considered set. So I'm going to have to go back and kind of make sure that's all right. Because this cell obviously should be seen by all of these. It should be seen by all of these down here below. All right, what if we make a subset of cells that overlap less so? Let's say these. And we make those red. I can select them like this. And then we just skip the step of simplifying the cages. Removed some 0 and final cells. Sorry, removed cell is just 0 and cells. Yeah, so now it's not removing any cells, and maybe what we can look at is, it makes more sense. So row 3, column 2 has definitely different scene cells than that. Yeah, I gotta go. I gotta take a break. We're gonna crack this, but I think we're kind of on the right track. I'm still not really happy because I don't feel like I'm fundamentally tackling the problem head on, which is that I basically need a smarter solver, I guess. I don't know. But at the same time, the problem I'm trying to solve should be much simpler than a full solution. So I shouldn't have to do a full solver, right? But I'm wondering if maybe under the bonnet it is not a trivial problem. Maybe there isn't a true solution. Maybe you get to a point where, hey, you know, if the whole board is tiled into cages, or into you're selecting everything but one cell from each region, for example, and there's no killer cages. Well, and if the board is mostly empty, the only way to calculate the true... Well, not really, right? Because in a situation like... I'm just imagining, if the board was entirely empty, you selected every cell except one per region, and there are no killer cages, so forget any cage reductions. It would still be relatively easy for a human to figure out what the minimum and maximum would be. Because in that case, you would invert it, right? You would find the negative space. So this might be another strategy, is to say, for this region, instead of going through all the permutation of these 9 cells, I invert the selection and go through all the permutation of this cell. And then I subtract that from the total from the 45. See what I mean? And in a way, that would still take those cells into consideration. So if there's an 8 here, or let's say if there's a 9 here, this cell would not be able to be a 9. So the maximum would be an 8. So that now means, you know, the maximum value of the total is 45 minus 8. So that might be another strategy, is to say, okay, if I have large regions that are partially covered by the cells in consideration, can I invert them and remove a large, you know, and let's say if it's 6 and I invert them to get 3, is that still worth it? Or if it's 5 and I invert them to get 4 instead, is that still worth it? See what I mean? So that might be another way of doing it. Like in a situation like this, if I now remove the row and the 4, it would be relatively easy, right? If I remove these... I mean, to be honest, removing a cage, that's actually exactly what I'm doing. I'm inverting the selection. The final selection is 0, which is exactly what I'm returning. And then I invert it and I return 45, right? So instead of just doing it for a fully covered area, maybe taking partially covered areas into consideration as well. Yeah, exactly. Especially for... So basically start with the largest. Now the only tricky bit here is now that means we should consider all cages in the entire puzzle, not just cages that are fully enclosed. But you know what? That might not be hard to do, because we don't actually have to do the work then, right? That's just a list of cages, and there's only so many of them, right? So we could go through that list, and we could calculate the coverage of each one in percentage, basically, and say, hey, if this cage was removed from the total set... The problem is now we still have permutations. So, because obviously, let's say if we have 2 overlapping regions, let's say a large cage. For example, in this case, right, we're having the 5-cell cage and the 9-cell cage overlapping. So if these 2 aren't included, do we consider these 2, or do we consider these 2 by removing that cage? So we have a few options, right? So ultimately, we probably need to do the same thing that we did with the solver. We have to step through the options, iterate through them, but ultimately there should be fewer options than, obviously, numbers and cells. The problem is, for each of those options, we still have to calculate a solution, right? So we basically end up with calculating the sum of these 2, calculating the sum of these 2, you know, all the possible solutions, and then the minimum maximum. So we might have to do actually more work. So that's kind of the risk there. But it's definitely something I should look into, at least, to see how hard that would be to implement. All right, I gotta take a break now. And I don't know if I'll stream again this afternoon, or if I just kind of poke at this a little bit on my own. I feel like these aren't the most exciting streams where I'm like just creating a whole bunch of rubbish code and I don't actually have a clear thought. It might also be helpful for myself to just sit down and do a pseudocode algorithm and say, okay, we want to do this step, and then in that process it might reveal itself that, oh, this doesn't make any sense or whatever. And maybe even come up with a couple of test scenarios, like I have the blue region and the red region and stuff, so I can work on a smaller scale and figure out exactly what's going on, you know. And it might be also worthwhile to have a few like heuristics to sort of, in this case, you know, trivial example, we can subdivide the region into cages. Boom. you know, sum of k is done, right? Or a trivial example, you know, singular row missing one cell, etc., etc. I'm glad you find them more fun. But I'm afraid you might be a particular kind of programming / Sudoku interested person. All right. But I have a feeling that, I mean, worst case scenario, to be honest, what I have already, I could implement into a tool and publish it, and it would be okay. Like worst case scenario, I say, hey, you know, we're excluding anything over 20 cells, right? Or, you know, or for example, if we have, you know, for each digit, we don't look at all the possible options. We only look at the lowest and the highest. So if you have 1 through 9, we only try 1 and 9, or only lowest 2 and lowest high. So we might be missing some optimal deductions. But the optimal deductions we'll be missing most likely in scenarios where even a fully accurate deduction would still be vague enough not to be super useful anyways, right? There will be some rare cases then where my algorithm will look stupid, where it just misses something obvious. Like, how, if instead of using a 1, you would have put a 2 in here, then this extra neighboring area would have been much lower, etc., you know? And you could have had a much lower sum or something like that. But there's a bunch of heuristics like that we can also do. Sort of fuzzy heuristics that will result in suboptimal results. It's just a little embarrassing to have something that's supposed to be a basic calculator to have to do guesses and return fuzzy results. But yeah, here we are. Okay, at least right now we are not limiting ourselves to 9x9 puzzles. We are limiting ourselves to puzzles with digits 1 through 9. That's not something I'm handling well here yet. Hopefully in the future I have a better way of handling that. Just kind of having a symbol list and looping through the number of symbols. But since we're dealing with maths, it's hard to accept other symbols, especially right now when the puzzle doesn't support multi-digit input anyways. All right, that's it. I'm glad you appreciate you liked it, Eric. Yeah, I definitely got to get into doing streams more often during the week. It helps me to get stuff done. And this feature, I want to finish it because now I really need to get into working on the iOS update and working on the mobile updates and stuff. And I don't know why that keeps bugging me. And of course, also on the listing updates. How to list sets of puzzles, how to organize categories and puzzle packs and all that stuff. Anyway, really appreciate you guys stopping by. I wonder if Mark is still lurking. It must be the other concurrent viewer I have, maybe. Yeah, that's what I'm talking about, basically. I need to update the app. And I'm just realizing that YouTube chat, that I don't see all the chat over here on the Restream chat, so I might have missed some of your messages. Yeah, this is basically what I have to work now. I have this beautiful donated MacBook over here. I need to set it all up to do new builds and then do an updated version. The biggest problem I have right now is that I know that the next time I do an update on iOS, it is going to wipe people's stored data, because it did that last time, and I haven't done an update for that yet. So I don't really want to do an update without that fix in place. And that fix I've worked on, but I haven't touched it since December, and it's not completely finished, and it's a bit dicey. So what I will probably do is update the Steam version or the Android version first, because there I know that the data won't get lost. And iOS needs to actually have that full data. Yeah, Android. So I'll probably do the Android version first, and it'll kind of it'll help test any kind of new change. If there's a problem, at least it'll only hit 1/3 of the users, because the user base is fairly evenly split between the three right now. I also would like to, because there's a lot of people probably using the app that don't know nothing about Discord, know nothing about cracking the cryptic, and know nothing about me. So I definitely need to figure out a way of putting something into the app that lets people know where they can reach me, where they can find me, and that there's more to it than just the 10 included puzzles and all that stuff. All right, that's it for now. Thank you very much for joining. And I hope I'll see you guys in the next Code Hangout. Let me just see if this works. I think it was just a little delayed. All right, thanks for hanging out. I'm going to have some lunch. Take care. Have a good day. Bye-bye.